in reading. Good morning. It's a bit strange. If I'm not wrong, there is only one or two English-speaking person in audience. However, we will all speak broken English. It's funny. It reminds me some time in the 19th century when Ivars Lācis was very important part of driving Latvian society. Nevertheless, thanks to organizers for giving possibility, and I will try to concentrate your attention on some small issues on eye movements and reading. First of all, we will go on warning. It means that, in fact, in this review, we will not see the detailed references on neither topic, neither eye movements, because it is an extremely wide topic which starts at the same century when Ivars Lācis was very developed in our region. It means in 19th century, and it had a tremendous history. It starts with as usual, bit crazy physicists. We divided specified equipment, everybody for himself. There were no, at the beginning, psychologists involved. Equipment was unique and very difficult for managing. And it was so until video era started, and then around 1980s, practically all equipment which was used for eye movement recording was changed to video-based systems. And as usually, monopoly arised. At the beginning, there were around 50 companies. Then it quickly diminished up to 20, 25, and it is current situation in the world. We do have 50 companies which are producing eye movement recording systems. Systems are very well in fact, except, I lost the word, let's try once more. So the systems are, in fact, not specialized. These are for general purpose, and usually there are no chances for operator to change something in them. So you can take them as they are. And in such a cases, usually a lot of misunderstanding can arise. Fine. Another side is reading. Reading is a topic which interests everybody who is more or less involved in education, in self-development studies, and so on. And most research on reading is done by cognition specialists and psychologists. So it's another very big topic which deals with hundreds of serious schools on the globe totally. So it's not possible for review everything. But we will touch something. And we will try to touch two, as I'm thinking, main issues. During reading, in fact, when we come back, we can see that during reading we are collecting parts of information, sentence by sentence, and by serial shifting our eyes. So it is due to the fact that our eye is so constructed that on retina we have only very, very small piece with high acuity. It's small piece measured in angular measures is around 1 degree. And if you are looking around, our total field of view is more than half of globe, and then you have on it 1 degree. It means that reading is possible only by shifting your eyes. And when we are reading in linear, let's say, order, and we are shifting our eyes, let's hope in linear order, then it was idea that by studying how eyes are moving, we will be able to understand how we are reading, how we are thinking. But it is not so easy, because there are a lot of additional small parts which are usually in our studies. And first of all, by shifting our eyes, we are using saccades. Saccades are well studied on primates, mostly historically well known results are obtained by Spark. Then, once more, so-called specific anti-saccades are studied, micro-saccades, and so on, and so on. And when we are back to what we are seeing when reading, so having such a sentence around the fixation point only, and that's it. If we are fixing word 4 to 5 letters, then you can see how your visual acuity is diminishing on both sides. So you should, in fact, try to move your eyes step by saccades. And depending on how big are letters, optometrists' letters are measuring in vision, typical visus measures. You can see that if you have 20 to 80, it means 20-minute high letters. Then on your retina, you may obtain only 4 letters. How we can read? We are reading, so by shifting our, in fact, fixation point, we have some starting point at each sentence, and we are going from sentence to sentence. And what is happening between our words depends on when we are starting. So it seems that the idealistic model of reading was model when we were be able to fixate on mid part of each word, and then trying to jump to mid part of the following word. But words are of different lengths. For example, here some word do have 3, 6, 8 letters, and the next one has 5 letters. So if you are starting from letter 4, our probability for final position is more or less following such a distribution. If we are starting from letter 1 before end of first word, our distribution of landing site is fully different. And you see that we can land even after the second word. And if we are starting at the beginning of this word, our distribution is once more different. But it means that because we have words of different lengths, we are starting at different points, It is statistically distributed where we are starting, where we are landing, and in fact our eyes are not following the text directly as we decided in beginning, word by word. Only 50% of all saccades are directed towards end of text. Approximately 20% of saccades are refixations. So if we have such a situation and the second word is a bit longer, we will be asked to read once more this word, and it means that we will be back to this word with saccade backwards once more. It's 20%. Then approximately 10% of saccades or even 50% of saccades are redirected back to some word previous in text, depending on how the sentence is developing. And our linear model is no more working because there are at least these two restrictions. However, at the really beginning, only linear models of reading were developed. It is so-called model of EZ reader, developed by Reiner and following one. And these models discuss the situations that we are processing in our brain simply word by word. So we are starting with some word. When we have finished some pre-processing in our cognition, we are ready to go on oculomotor command to follow to next position, but we are working only word by word. Word by word. And the time course in such a case depends on word properties of sentence construction and so on. And usually for one fixation plus programming of next saccade, we are spending around 300 milliseconds, and so we are making usually approximately 3 saccades per second. It's nice. If you are reading 10 hours, sometimes you are in very interesting book or let's say a story about, I don't know, optometry, and you are reading 10 hours. What amount of saccades you are making during this reading? It's a nice figure. It's absolutely not easy to understand what our brain and what our eyes are doing during reading. Very often we do have mislocated position of landing. It's up to 20%, and mislocation fixations or landings depend of a lot of particular issues like our concentration, how long we are reading, do we know the text well, do we like it, do we are intended to be very perfect in our reading. We have colleagues which are upstairs going on eye movement recording, but we should take in account that each person which is being seated in front of machinery is going on his own constructions, how to do, what to do, and it is not free reading, and due to the fact there are some problems. Nevertheless, like physicists, also people in reading science is trying to go on models which are able to fit experimental data with model data for saccade lengths, for fixation time, and here we have one plot of results. I'm sorry, I forgot to mention. Author, this is Reichler with colleagues, and it is a demonstration of so-called Swift model. And you see that having experimental data, blue, on each small panel, depending on launch site, we remember it is position on previous word, we are landing on different sites afterwards, and in fact modeling can fit something. What these models are taking into account? They are taking into account two distinct cognitive tasks, and they are separating both tasks. So decision when to move is made independently of decision where to move. It is number one. So in our cognition, when going on reading the text, these two important tasks are not fully related each to other. These are independent. Then in studies of animals are not reading. It's only a small problem because a lot of knowledge about how our brains are working are obtained from animal studies. And then with some probability shifted to human being, and there are some animals which are approximately the same good as we are. For example, if you have a screen, a monitor screen, and on screen you have spots, light spots, arriving one spot after another, and you are asked to fix them with finger or I don't know, pencil or what else. And if in Tokyo University physics students were had a competition with monkeys, how quickly one group and another can follow these light spots. Monkeys were beaten Japanese students from physics quite seriously, and spots arrived around 100 milliseconds or a little bit less one after another. And what even better, that monkeys were able to remember positions of spots more than physics students. For example, you have 1, 2, 3, 4, 5, 6, 7 spots in different positions. Then they disappeared, and monkeys giving you 7 points, and then physics students are able to for 5 points. So studies on animals for our brain understanding is a serious tool, but unfortunately these guys small are not reading, and I do not hope they will read in future, because it is genetically not the case. So what to do with such a model if we are looking to approve it? So then we need some mathematics. I will skip it. It is simply as a small excursion. We have formalism, how to follow our reading, and then we should compare something. And Nutman, his colleague, had studied so-called mindless reading. It's one more tool for reading, so our students as well sometimes used it. You may construct information like sentence consisting from words, but in Word you don't have letters as usual. So I'm looking on Andris Steinberg's, but you have simply xxx, xxxx, and then it follows xxx, xxxx, and everything which is written in sentence is given to you by these x's, and in such a case we are speaking about mindless reading. So we have information before of us which is which looks like written in code, and there are words, there are letters, there are spaces, and something like sentences. And if we compare model which is developed for reading, and this mindless reading is Z strings, for Z strings model is giving more symmetric distributions, and for real word reading, distribution is skewed, I lost the word. Is it the right word? If you understand. So distribution is not symmetric, and the longer part is to longer side, and experimentally it seems that it works approximately in the same mode. Master students know these pictures, and the story is about how many different kind of activity centers do we need for more or less reasonable models of reading and eye movement. First of all, we do need some place where the saccades are being generated. Then, absolutely compulsory, we do need fixation center, because on each stop we should stop for exact time to pick up information. So we do need fixate center absolutely for granted. So sentences are being written consisting from words and letters. So we do need somewhere in our storage places something which can work with letters, something which can work with words. The question about do we have something for sentences is quite tricky and not answered, because sentences are being constructed very differently. For example, if we compare Latvian language with German, where construction is a little bit different, and we should read the sentence in German until end successfully, and only then go on decision. So it seems that we don't have here one German construction center for sentences, and right on left side one for Latvian, and somewhere here for English. It was nice, but we don't have, so we are mixing, and usually in models we are skipping ideas that we have something to analyze sentences. We are analyzing letters, words. We are ready to fixate our eyes or to move our eyes, and then we do need something which is driving all these machineries. And in linear models of reading, this driving force was understanding of word. So somewhere, if a reader understood the word, the command is being developed to move. In all these models, which are looking for real modeling, there is a bit different input, and this different input is so-called saliency, and from saliency of object, some kind of saliency maps can be developed, and this saliency map, in fact, can be developed somewhere in neural structures. Little bit about one more difficulty, not related to cognition, but related to our main reader, eye. So this difficulty is related to fact that for successful moving of eye, we do need activations, simultaneous activations of many muscles, and these muscles are being activated not from one point, and among facts that during reading we are dealing with this eyeball which is fixed with different muscles, we are moving as well ourselves. So it means that all models up to now in fact discussed only abstract eye movements. In reality, humans are moving, like Ivars, when he is very busy, he is always running, and then during running he is sometimes as well reading, and this reading is fully different from reading which was described until yet in models. So one more another complication. And behavior of innervation of muscles, one more, can be very well studied on our friends monkeys. It is well done by Sparks, and you can see which muscles are being activated and during which moment how they work. Even more, it's a very nice presentation of a colleague from California who on animals had developed real architecture of innervation of eye muscles, and find out how many different inputs do we need for each one separate movement. But back to reading, we have 3 movements per second. How many for minute? 200? Is it right? How many for 10 hours? Wow. So, and all of these practical issues should be taken into account for each movement. And among everything, understanding which word, why move, why not to move, read, not to read, like to read, or hide to read. So it's once more for Tutis, who is constructing all these nice things and Sparks, which, for example, here demonstrates that during activity of monkey, when you are going on changing your horizontal eye position by, let's say, 40 degrees, it is quite a big shift of your attention. In fact, important is gaze. Gaze is a constituent which is giving you right position of your eye on your target. But it depends on both things, how I am moving and how my eyes are moving. And when being very precise in language speaking about eye movements, it is necessary to divide eye movements from gaze shifts. And in laboratory, where we are fixing our hands once more back to Varis, he is very keen to fix his head. We usually are skipping head movement. However, it is not very reasonable. It seems that it is maybe too specific, and we will skip the story. And the very last comments before experimental data is about main general flows involved in every task which contains visual information. So usually there are at least 1, 2, 3, 4 main streams which once more in reading are working permanently. So you are intaking information, in this case by afferent limb. It is bringing you at the beginning to V1 and then up. And at the same time, you should direct your eyes, and direction of your eyes mostly comes from superior colliculus, and this is second important story. But it's not enough. It's not enough because say in reading, you should from superior colliculus as well as from V1 send information up to frontal eye fields when we have logistic things, and of course from these parts of our brain, information is once more being sent back. What it means in times, let's say spans. For this action, we do need more than, let's say, 30, 40 milliseconds, depending on case. For this action, we need a little bit less. But most of time before taking some decision is here, so we are analyzing information, and this analysis in fact can take not several tenths of milliseconds, but hundreds of milliseconds, and in case of reading, this communication takes around 100 milliseconds. So several tenths of milliseconds, once more several tenths of milliseconds for these formal things, and then around 100 milliseconds for communication between different areas of brain. Where we are back? We are back to our 3 saccades per second, and back to our usual reading rate, which is more or less the same for every student in Form 12, or a student on master level, or is very little depending. Is it Form 12 in Latvia, or is it Form 12 in Finland, or somewhere else? So in reading, most of us are at the maximum capacity of all this machinery, and our hope that we will very simple, by addressing how eyes are moving, being able to understand how we are reading, is misleading. So despite the fact that we are more or less at the same level in our general capacity, individual features of reading are really very different, and it is easy to understand. These formal things maybe are quite equal in everybody of us, but the second depend on a lot of individualities, and when we are looking on our mechanical behavior, it is not easy to go back what is going on in cognition part of reading. So after this maybe not simple review and review with breaks, let's look on some experimental data obtained by our colleagues. Number of students involved in experiments is even bigger, but I am currently looking to mention 3 ladies. And what they are trying to study, first of all, there are several studies of gaze behavior during reading or during doing tasks similar to reading, which are related to different capacity readers. It as well can be related to project being led by Professor Krumiņa in school, when in fact we are looking to what? We are looking how to divide with some reasonable model people with reading difficulties from the rest. Fortunately, we don't have many people with reading difficulties, but we have them. How to divide, so as well studying eye movement in reading, there can be some ideas for discussion. Then very new subject and little studied everywhere is binocular, maybe not fixation, but behavior during reading. And what is interesting is that in fact during each fixation binocularly most of us are not fixating the same letter, and even more our eyes during this fixation time are moving slowly, approximately 1 letter to left, to right, and going on crossed or uncrossed disparity as optometrists use in everyday discussions. Very interesting story is dot ray scanning, and comparing how dots are being scanned with reading. This dot scanning is still not finished, and several studies are on recurrent or reading same construction text for several times and looking what is going on. This is in Latvian, and everybody can read very quickly what is on screen. These are different tasks for reader. Later on poster, you can ask Lasma and everybody for us which are nearby. We have different texts which are becoming more and more difficult. First of all, there are no more breaks between words, and after we have colored pieces of text which are attending our attention differently from written information. And in this array, what is happening with reading text? I had only very small part because everything can be discussed later on. So we have different readers. For example, the first one is skilled person. What it means, skilled person? It means that skilled person reading this text one, which was usual text, is using saccades, fixate, saccade, fixate, saccade, because here is position in line by coordinate x, and here you have time in milliseconds. This is horizontal position of I, and here you have vertical position of I. It means that during reading our reader is slightly making such a movement, but nevertheless reading is strict. Word, 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 word. If the text is becoming more complicated, we have smaller saccades, smaller by lengths, so eyes are going like this, looking word by word, and we have longer fixations, but Y is becoming, so having difficulties in reading these texts. Our person is more concentrated on Y position. Here we have person with some difficulties in reading. What we see that in both texts, independently how they are complicated. I do have 2 minutes. Sergey, is it right? We don't have regular saccades, and we don't have something like regular fixations. What it means that person all the time sees on his fovea 2 words simultaneously, in fact, because one picture, then the next one, and they have very big overlapping part, and it is very difficult for making a decision. This is a picture of our both eyes, and as I mentioned, these are saccades. Here we are fixating on some part of word, we are fixating on part of word, and so on. Left gaze is blue one, and right gaze is red one, and this difference is on screen something around 50 pixels, and 50 pixels is something around one letter or 2 letters or something around it. So during fixations, somebody of us, not all of us, has such a type of reading. And at the real end of my time, before saying thank you for your attention, nevertheless, here is what we are doing in repeated reading similar text for 7 times. More or less we are on the same places. And now I'm at the real end. Thank you for your attention.
Thank you very much for nice review on not easy field of vision science. Maybe questions? Anyone have? Look.
Maybe the question is about poor reader and normal reader. And if poor readers when you try to maybe to help them, then maybe the idea about this break between words.
Yes.
You do the idea.
Yeah.
But what happened with saccades? Because you know the saccades have medium amplitude.
Medium amplitude is 7 to 9 letters.
Maybe
You are not usually going on breaks up to 7 letters. If you have span between words 7 letters, it's no more reading. You are maybe jumping and with head movement. But having 2 or 3 letters, big span between words, should help. And another story which we are trying to develop, but we are not successful, is to teach a person for making saccades. And this story is complicated because saccade is from one side reflexive and from other side it is mind-driven. And you have once more this competition, what is stimulus and what I am giving, which type of information to my eyes for jumping. But it should help for a student bigger spaces. But it will not help for good reader. It will slow down the reading for good reader. So maybe we do need 2 types of information. One is for not so developed, so with bigger spaces, and another one with small spaces for more developed. And we can use as well different letter sizes. Kids are very keen to read small letters. So we don't need for everybody big letters. I think so.
More questions? Yes.
There was on one of the first slide such scheme with scheme, and there was some unit, triggering unit or unit which begins all this process. What is this unit?
Here.
No. Much before.
Much before?
Yeah. Oh.
Uh-huh. Here.
Random timer. What does it mean?
It means that, in fact, some last publications are showing that decision where to move is Bayesian distribution like. So it is not dependent on your actual reading, but it is probability game. You are ready to move, you are not ready to move, it depends on probability. And this probability is this random timer which is giving you signal for move. But where to move, it is a different story. It's parallel input. And triggering unit, in fact, is a superior colliculus. On superior colliculus, you have activity of your neurons on fixation point, and you have arising concurrent. Concurrent is not English. What is English for concurrent? Huh? Competitive. You have competitive another part which arrives, and when the new part overtakes the fixation part, the trigger is giving you a possibility to move. So triggers are on, as I understand, they are on omnipause, for example, neurons which are holding your eye. And when you have a trigger signal, it's taken off and omnipause is no more holding, and I can move.
Such a question, maybe not correspond directly to your topic, but anyway, you mentioned this nice story about monkeys and Japanese physics students.
It's not nice for us.
Yeah, but it is about your theory or concept, it is universal. For example, as I understand, Japanese people have a little bit different understanding of each Chinese character or philosophy. It's a little bit more, yeah, like letters here you present on the screen. On the other side, for example, Japanese people cannot understand the sequence of T and V, Latvia, it's very difficult, because say Latvia. It's maybe the first one. Another one, what about this so-called optical memory? If maybe I'm not special, but some people can fix, for example, page and then read it after. It's also somehow some algorithm how it is, how that works in your. And also this page composer principle, also for optical memory, it's something that's holographic maybe. Do such a
For the second question, my answer is very simple. I don't know. And I'm not going on speculations. Memory is extremely complicated in respect to visual information collection. In everyday experiments by vision, it is possible to divide so-called very quick part of memory which you do not remember for more than 1-2 seconds. It is like a copy of topography, but for very short time. And then you can study long-time memory, but it's not my field, and I can't say nothing. About reading of Japanese print, there are a lot of studies, of course, and if they do have, if I'm not wrong, 2 types of writing, one with spaces and another without spaces. And reading in Japanese without spaces is more difficult for them as reading with spaces. And what is interesting, fixation times for reading of me, let's say, each my fixation is around 240, 260 milliseconds, is approximately the same for average Japanese reader. So it is around 250 milliseconds. So somehow we are equal when we are picking up information and planning where we'll go. Japanese and Latvian guys are more or less equal, but how they are dealing with letters and how we are dealing with letters, this is issue maybe of great interest, but I can say nothing.
Thank you.
Thank you
Late on
very
time.
much for the speaker.
Wow.
Thank you.
Some thanks for the
Thanks.